Hi, hello. Thanks to be here. I'm Rob. I'm here to presenting you something about data, okay, about JSON and relational database, things that in recent history didn't always match. Okay, so today in 2021, I can say that the match can exist and there's also a synergy between the two. Okay. I'm just sharing you my screen. Okay, good. I'm actually the CTO retailer. That's an agency in Italy that deals with Amazon retailers to improve with the intelligence, analytics, and internal tooling their selling perspective on Amazon. I've been a consultant for years. I wrote some books on Azure, Microsoft Azure, and I hope you will enjoy the session. So I also tell you to interrupt me. Feel free to write in the question and answer chat during the session, because I have a second monitor, so I can monitor also your question to reply live, because I prefer to do this because it's better and it's create also some interaction between me and you, even if we are remotely. Okay. So what is the purpose of this session? The purpose is to show you that the coexistence between relational database world, so SQL Server, for instance, and this JSON document, so structured but also unstructured data inside JSON documents can be possible and can be also be effective. Okay, so well, let's go ahead. Some assumption, okay, this sounds like a disclaimer, okay, it's not a contest. I don't want to go to the end of the session telling you which is the best between the two, okay. It's not a competition, so I really love the NoSQL initiatives. I used for years something like Elasticsearch, because I thought, and I actually think that for search, for instance, is a real good choice. Okay, I use relational databases for those kind of workloads that needs some queries, some performance optimization, indexing techniques, join between the tables, and for BI, for the business intelligence perspective. Okay. And I think that we should work on the integration between the two worlds. So I would say that NoSQL cannot exist without SQL, and today SQL cannot exist anymore without a good NoSQL support from the industry. Okay, so well, let's think about this common scenario. Okay, this could be a common scenario when you deal with data and when you deal with integration from a third party, from other sources. Okay, well, just a second, because okay, well, when data comes from third-party sources, we can have those kind of data in JSON format, for instance, because it arrives from a reporting system. In our case, we receive each day a tons of information from third parties in JSON format, also in CSV, for instance. Okay, it's not a matter which is the format. Then we should clean the data, okay, to set a sort of standard in the input data. After that, in a database, in a relational database world, we should create some sort of structure. So, for instance, the tables, okay, we should engineer the tables, and then we could ingest the data into those tables to produce the result. What is the result? The result can be the table itself, but it can also be a set of views, for instance, that aggregates the data to be consistent from the user, the consumer's perspective. Okay, so in this session, we are going to look at this scenario, but just few points to keep in mind. Okay, while we are integrating third parties, the incoming data may change. Okay, In some scenario, it shouldn't, because we have contracts. Okay, so we made a deal with a third party. Your data should be composed of that fields, that length, etc. But it can change. Can change because the third party can be also not so binded to us. Okay, for instance, if you are integrating a public API, for instance, a public data feed, okay, and it may change with unexpected new entities, so we should filter them to avoid some sort of runtime exception during the ingestion phase. Or new fields are added, but it's not really an issue in most of the systems, because when new fields are added, your logic should be resilient to new stuff. Okay, it's not so easy to be resilient to existing stuff that change. Okay, but with new fields it should be so it's quite easy. Or worse, we could have missing fields. So some field that for us is mandatory, a primary key, okay, just to keep in mind, is not showed anymore in the data. So this could be a problem in the relational world, okay. Good. So the scenario of today is composed of two different data sets. One is a movies data set, and the second one is the reviews of that movies, okay. I took those data sets from Kaggle, and actually the reviews are the reviews of that contain spoiler of the movies. It's not really important which is the semantic, okay, of this data set. What is important is that we have movies and reviews of that movies. And I want to consolidate this data into a relational database, okay? So let's explore a second the data, and let's go ahead. Well, we have the reviews. I'm using this tool. I really find it useful because it's a good tool to see huge JSON files. Okay, what I mean with huge? In this case, I'm waiting not because of the tool, but because of the bandwidth, because of the internet. So just wait a few seconds more. But it provides us the capability to read gigabytes of JSON about gigabytes of size in a few seconds. Okay, so hold on just a few seconds more. We are waiting not for the tool, but for the bandwidth. Okay, we got it. Okay, let's start from the movies. This is the movie, so ID plus summary, duration, rating, release date, and so on. And this is the reviews data set that is about 1 gigabyte. And for each review, there is the review text, the movie, the reference movie, and the summary. And since this data set was born to identify if a review contains a spoiler, it has also this spoiler boolean, but it's not a matter of the session, okay? Good, so we want to include those data inside a relational database. Well, good. Let's go ahead. Okay. So now that we got the data in JSON, we should engineer the table to put those data inside the relational world. And here I want to introduce some concept, if you don't have it in mind, that is very related to the application lifecycle management of a database. Okay, so the final database is this one, but I used Visual Studio and especially project type that is called database project to hold all the objects of this database. Why I did so? Because I think that the database engineering, the database development phase should be pretty much the same of code, okay, of software, okay. So we should keep all the object, the artifact inside the project that in this case also give us the concept, the abstract concept of build, okay. In this case, the build is broken because it detects that we don't have a reference, a proper reference from a table to another table. Okay, so it's helping us to build a consistent database. And on top of this, since they are files that each one represent a table, okay. Just hold on, because this is a bug, of course. Okay, good to know. Sorry about that. Okay. So each file represents a table, and we can put each database artifact in a specific file. So it's better from the organization perspective also. Finally, we can treat them as source code, so we can git them and version them to a repository, a software repository. So we can also go back in time and in the history to see the changes, apply migrations. It's a very powerful platform to build database solution. Okay, I'm not telling you that you should use Visual Studio and Database Project, but to use a software that manage the database development. Okay, there are tools from Redgate, there are tools from other real big companies that made this kind of software. So don't be too related to this one, but just keep in mind that you should use a solution to manage your database development. Okay, good. Sorry about the Visual Studio that is not working, but I want to show you a thing. Okay, now it's working. Good. So, well, okay. I want to put my finger on it. Okay, let's take this one. Okay, in the JSON, we don't have any review ID. Okay. Because it's not needed, okay? But in the relational world, if you want a primary key, for instance, to have a uniqueness into the table, or to set up a clustered index based on the primary key, I need to create one primary key that is an identity. So it's a surrogate primary key. I don't really like surrogated values because they don't come with a semantic, okay? It's just a fake data that we put inside a relational table just to set up a constraint, okay? Well, I mean, I want this key because we are in the relational world, but I really don't want to invent something that is not really relevant to the data, okay? But we have to. The second thing that comes to my eyes is this, except from the error that I made just to show you the build engine of this project database. But this is a foreign key, okay? And in NoSQL world, may happen that in the data comes something that has not the parent relationship, okay? This is the case. For instance, when I first analyzed this JSON dataset, I found out that some reviews hadn't the relation with the movie. So there was the review, but there wasn't the movie connected to that review. So in a sense, it should be inconsistent, because you say, okay, but if I don't have the movie, why should I put on the database the review? Okay, in a sense it makes sense, but we are cutting off data that could be useful for analysis. Okay, so in this relational way to live, okay, we set up this foreign key that has a constraint under the hood, and we are cutting off data that has no match with the movie. Okay, just to let you know which are the limitations, okay, of the relational when we ingest unstructured data. Okay, let's go ahead. We are building something that is different. That is a table, for instance, that has some plain old columns with their types, and place a single column for all the text that represent the reviews of that movie. And this is the place where we are putting the JSON information. Good. So go ahead. We engineered the table, and now we need to ingest the data and produce the data. Okay? Let's go ahead. So, ingest the data. First, how to ingest the data? We can use data preparation tools. In Azure, there's one big project that is called Azure Data Factory, or also Synapse Analytics and Data Movement and so on, that let you move data from different sources in a scalable way. Okay? If you are accustomed with SQL Server, you probably know SSIS, SQL Server Integration Services. If you use Talend, also, it could be a solution. But for this demo, just to leave some code for you in my GitHub. So everything you are seeing now is on my GitHub, so feel free to clone that. I made it with C#, not because it's the better approach. At the opposite, probably it's the worst approach in this case, but just to show you how I ported those data inside the tables. For instance, in this case, I parsed the JSON movie file, and I create some entities to add them to the database, and so on for the other kind of tables. Let's look at the final database. We have the relational table. We have the relational reviews table, which has a foreign key to the movie. But we also have something that I call an hybrid table. Okay, so a table that is composed by some old school fields, like those ones, and a field that is containing, oh, it's not the proper approach. Yes. I'm opening Notepad++. Okay, it's not my day from the demo perspective. Let's use this one. Well, in the meantime, I call this hybrid because, but it's not really a convention. Okay, it's just my way to name this kind of table because it mixes the relational approach and the JSON NoSQL approach. Okay, let me check. Okay, right now, no. Well, it doesn't matter. What I mean, well, just last chance. Give it a try. Okay, maybe this is okay. So in this case, in every movie row, there's an array of reviews. Each review has this kind of fields. Okay. Also, there's a full, I call it full JSON approach, that has just the movie ID and a column for the movie document and a column for the reviews array. Okay, good. So let's create a view to produce the result that my customer, my internal customer in case of business intelligence, or external customer in case of someone else, may want to look at this data. Let's start again from the original tables, okay? The movies and the reviews. We can set up a view. We can have the relational movies, the relational reviews. We can have movie ID, all the stuff, and review ID is not really needed. Review date, movie ID is already shown here. Review text, rating, that can be renamed because they're also the movie rating. So in this case, it can be the review rating and the review summary. Okay. This view produce a denormalized version of the join between movies and reviews in this format. Okay, this can be the aggregate that our customer may want to see and may want to use in their data. Okay. Well, now let's start with the JSON part. We have a choice. We can choose to keep the tables when we probably need to enrich the data or edit the data. So, for instance, if we want to change the review text of a single review, it's definitely better to have the reviews table go straight to the line and then edit that field. Otherwise, if we have the JSON approach, we should identify the movie, go to the reviews column that holds an array of reviews, go to a single reviews, edit, and re-upload all the entire JSON. That's quite weird, okay? So in that case, keep the tables. Instead, at the opposite, if you have data that doesn't change anymore, so for instance, that it's immutable, okay? In that case, the JSON is a good approach because with immutable data, you don't have to change it. So it can be wrapped into a column, into a single column. So it's a good approach. And it's also more flexible and extensible for the future. For instance, right now we have 10 fields in the JSON. And with the relational approach, we should map 10 fields, 10 columns, okay? After 1 month, other 5 columns arrives in that JSON. In the relational approach, we should map new columns, recreate the tables, the ingestion, and so on. With the new approach, we should just take the JSON inside the column and we have it. We are just having it without any edits to the database engineering. Okay. So now let's go ahead with the JSON functions. So, okay, we are here. Let's take the full JSON approach, the one I like. Let's take this one. Just to work on a single movie because of formats, not just issues. Okay, let's take select star. That movie, good. And now let's try to go inside this JSON with the specific SQL Server JSON function that are native and really performant. They are really optimized. Sorry about that. So let's try to say, hey, start, and then try to get the JSON value from the field movie. Which value? Which field? Okay, let's keep this. Let's take movie ID, we already have it, so plot summary. Okay. summary as a plot summary. Oh, well, and it has been unwrapped from the JSON. Let's continue like this. So, movie part, plot summary. We have duration, general rating, and state. Duration, general rating, state, and let's sign up. Okay. So okay, everything is good except from the genre. Let's go here. Okay, the genre is not a string, okay, but it's an array, a JSON array itself. So when we have fields or something that we should keep treating with as a JSON, okay, we can use not the JSON value function, but the JSON query function. And the JSON query just take this path as JSON. Nothing more, nothing less. Good. Good. This is a good part. Let's comment it for a while, and let's focus now on the review. So, reviews is an array. Okay. So let's just create movie ID here and review. So we can, for instance, go to a single array item. So let's take the first dot review values. Let's give a try. Movie. It's okay, but it's not what I want. I want to apply each element of the review to this row, to this specific movie row. So it's like a join, okay? Join every item of the reviews document in this movie row, okay? To do this, I can say, hey, right, the row to the open JSON of reviews. Let's keep start from a second, for a second. Okay, there are many probably. Okay, so what happened? A second. Okay, what happened? We have the movie ID, and for the single row, we are filtering for a single movie. Okay, we are producing this this tuple of three: key, value, and type. Key is the index, value is the single array item, and type is something that doesn't matter for this demo, is the type that is inferred from the JSON object. It's not doesn't really matter. So we can just take movie ID and value from this cross supply. Okay. When we have this, we can approach the problem at the same way we use the above. Okay. So JSON value. Now we are dealing with a single item, not the array itself. So we can go straight to review date without any indexing technique. Okay. Good. And ta-da. Okay. Now let's go ahead and keep all the stuff here. No user ID is for review text. ID is review text. Excuse me if you hear some noise, but here in Italy is lunchtime, so my colleagues are eating probably right now. Wow. This somewhere, it's the last one. Okay, rating. Well, to make the both rating coexist, I need to rename this to review rating, for instance. Review text, spoiler, user ID, and review date. Take a look. It's working. Okay, so now I want to show you some sort of refinement. Okay, some sort of fine tuning of this data. Okay, review date, for instance, can be casted to a date. But this can lead to an error because not always this field is properly formatted as a date. So to avoid the runtime errors in the view, in the select, we can use the try-cast one. Okay. The same for spoiler. We can say try-cast this as bit. And the review rating, try-cast. Rating is often something that is from 0 to 10 with probably a decimal point, okay? So something like decimal of 3.1. So in total, 3 digit with optional 1 digit after the comma. And the summary is okay. So now we have something that it seems more relational, right? Okay, just for this conversion and for someone that can think, okay, but it doesn't sound so performant, okay? Well, it is, okay? It is definitely both the JSON value function and also the casting function are really, really optimized for performance. So let's uncomment this part too, and we want to what is the problem? Right here. Just a comma. Yes, just a comma. So let's apply the try-cast also on this rating. Release date the same. And this one is okay, January is okay, duration, okay, let's take the duration. I really want the duration in a time span format. What I mean with time span, something like 0, 2 hours and 32 minutes or something like that. Something probably like that. Okay. So how to perform this kind of conversion with some creativity, okay? So we can replace age and space with a column, we can replace the min with a column and 0, 0, and then we can try cast the result string as a time, okay? I did this in a function that you will find too in the GitHub repository, okay? The function this one as time span, just to let you know how it works. It's replace, then replace string and try cast. Keep this, put this here, and we have the time. And now we can create a view JSON for the three views. Okay. Yes. Oh, all. So let's uncomment the where clause. Good. Now we have the old school review that is this one created before. Okay. And this the new school view that is pretty much the same. Time, duration, okay, release date. Just the difference just in the limit of the varchar types, okay, because of the underlying engine of SQL. But the schemas, the contracted schema with the outside are equal, okay? So we can produce the data in this method that is 100% equivalent to the old school method. Okay, and in my opinion is a real big deal. Okay, good. So we saw a JSON value that keeps out a value from a JSON. JSON query that keeps out a value from a JSON, but keeping the JSON format. And we saw OpenJSON that opened an entire JSON document, an entire array, to be then applied to a row. We didn't see it JSON, but it's just a Boolean function that returns true and false, and the argument is the document and can be used, for instance, in a constraint. So you can say this field is nvarchar max, so it should contain a JSON. The constraint is JSON, okay, to check, to enforce that user can put on that field, on that column, only JSON values. Good. Now I say I want to push this technology on a rocket, okay, just to have some fun, okay. So let's see together what I call a nightmare for database engineers, okay. We have a new table, that is this one, that is just a ID value table. Okay, let's keep select just the ID from playground to value. There are two documents, okay? So if we were in present, I would ask to you, guess what are in those two rows? Okay, in the first row, there's the entire movies JSON. So 13, 15 megabytes, okay? In the second row, the row number 4, there's the entire reviews JSON, so 1 gigabyte of data, okay? In the entire row, okay? In a single column. Well, so we can create something like this. That obviously is a nightmare, but just to let you know that you can also have simple tables with the key and the value. And I also have that in production, not with a gigabyte of JSON, but almost that, okay? In that case, the nightmare stands for take the element 4 as the reviews and join this as with the element of the movies JSON take from the ID 3. So this actually is why is a nightmare? Because if we run it, it will hold for a while, okay? And the plan actually is a spool, so it takes all the stuff and memory to perform the join. So it's not really a good deal, okay? But it's just for let you know that you can push that way to hold just a key value store into your relational database. Good. Finally, the last thing I want to share with you in this session is some future options, okay? We have many JSONs. JSON is huge compared to the native form of the relational database storage, okay? But JSON could also become not so useful to be keeping memory, keeping in the live memory of the database. For instance, if we hold some reporting data that doesn't change anymore, And after 1 year, 2 years, we realize that those data is almost never accessed, okay? We can put that kind of data somewhere else, in another storage outside the database or inside the database, but in another format, okay? So, for instance, we can freeze it in a real table with real fields, okay? Now we are looking at two ways to perform this kind of denormalization. Okay, let's keep the view that we created, all reviews, and let's say take all the stuff, just the first 100,000 to be faster because we are in a demo, into, for instance, the norm, the station dot table. Just take 1,000. So the copy is fine. Okay. We created a new table. Okay, here that is a real table with all the fields. Okay. Why I call it heap? Heap because it hasn't a clustered index, so the data is not structured and indexed in any way. But we can add a cluster index in the table, also in a form that is called clustered column store index. So those are two tables. One is pretty much the same of the one I created now, and the second one has the same fields, but it also has a clustered column store index. So we are telling the SQL Server to organize the data in a column store way instead of row store. And this is, for how it works under the hood, a real good optimization that compresses the data so much. The only thing we need to say is this directive, so create the cluster column store index, and the result is, from the customer's perspective, it's pretty much the same. Not really, because in this table we have something like 500,000 rows. We can see it in this view. 500,000 rows, like in the heap one, but in this case we are consuming just half a gigabyte, in this case 3 gigabytes. Also, in the optimized, the CCI optimized table, we can, for instance, say, hey, organize all the stuff with a group by on the year of release date, and, for instance, the average of the rating. This query in a plain old relational table should take probably minutes to perform with 500,000 rows, okay? But in this case, it's almost in real time because of the underlying structure of the table. So, which is the final lesson of this demonstration, this session? Is that when you want data in transit, when you want to perform something that is happening now, you can use relational data, JSON, you can mix that kind of technology. But when the data becomes older and you don't need so much to access it anymore, you can put that data into another storage that is optimized for analytics, long-term retention, and so on. So this is the actual suggestion that I gave it to you. Use JSON, use relational. When you have so much JSON into your database that you are using not anymore, put it in a specific data store, internal or external. If it is internal, you would do this with a clustered column store table or other technology. And that's all. So I really thank you very much for being here. And if you have some question, put in the chat, put them in the chat, and we'll be happy to reply. Thanks.